Got new topics today. We got habits of thought, habits of thoughts, habits of thought. I like habits of thought. And yeah, we've got how appropriate is to talk about habits of thought, how to best mark stream moments via Stream Deck, and then how to think about brainwaves. What was that all about? How to think about brain? Oh, I think I looked that up today. So I don't think that's necessary to do on stream anymore. I just wanted to succinctly sum up everything we said yesterday. Predictive processing, right? We talked about what the different layers are doing. We saw that the layer 5 neurons had some sort of authority over whether layer 2 and 3 neurons were inhibited. This kind of makes sense given that layer 5 neurons are closer to the center of the brain, in a sense. Or I guess they're just lower down, like layer 1 going down to layer 5, which makes sense of how the layer 5 pyramidal neurons are getting priors from farther away up top near layer 1, and they're getting sensory data closer to them. So that makes sense. Yep. We talked about precision and valence. So precision error, the raw mismatch, it is computationally value neutral. I'm sorry, this is prediction error. Precision is the volume controller of the synaptic gain. So precision goes up if there's like high norepinephrine. Salience, formerly defined as precision weighted prediction error. This is the interrupt signal that captures attention. But salience is also a broader topic. So, okay, the other thing is if. So, the amygdala is determining the significance of what's going on, and the anterior cingulate cortex is determining whether something unexpected happens. I think that was it, right? The amygdala. Does the amygdala determine / interpret how significant information is? Or am I thinking of something else? Yo, Darmadon, what's good? Gang. Yes. The amygdala acts more like a relevance detector, right? That's what I meant by significance here. And then, so amygdalance is about relevance. Anterior cingulate cortex is about expectation and determining when something is breaking that expectation. What do we got? Oh, we're about to get to the ACC. Valence, the rate of change in error. I just asked it to summarize everything we talked about yesterday. Transition from a local mismatch to a global state change is governed by a specific circuit. So conflict, determined by the ACC, distinguishes between expected uncertainty and unexpected uncertainty. The system reset, yep. The locus ceruleus, norepinephrine. So when it detects significant unexpected uncertainty, it triggers a phasic burst of norepinephrine from the locus ceruleus. This phasic burst is what essentially resets the global workspace. So it resets our conscious experience in some sense. And it also, and I looked at this off stream, it also facilitates the addition of new information in such a way where that new information can basically capture the workspace and kind of like form an attractor state. So some sort of equilibrium, some stable state. So you might think that when we're usually operating, it's more chaotic in terms of the information that's being added, but in this case, it kind of creates a synchronized restart in terms of what you're paying attention to. But obviously, this happens very quickly. G, normal day. Hell yeah. It's all about the normal days. Something nice about normal days. This NE wash increases the gain on sensory input and suppresses the influence of faulty priors, forcing an emergency update. Right, okay. So we are done with that for now. We need to talk about habits of thought, which is also a discussion of thoughts in the brain. I think we had a Gemini discussion somewhere about thoughts in the brain, but I don't remember where that was. Okay, how do I want to go about doing this? How appropriate is it to talk about habits of thought? All right. My understanding is that within the past 10 years, we've been slowly getting a better view of neural correlates with actual conceptual thought, giving us a sense that we can point to the brain for specific aspects of our thoughts, really just showing that thoughts... Okay, let me... I'm just riffing at this point. Further strengthening the view that thoughts are in the brain in some sense. And then that's not everything we want to say. We want to say, following this path, we could see how the dynamics of neuroplasticity would be involved in our thoughts, just as it is in memory and in autonomic habits. We can consider how having certain thoughts builds those connections and makes it more likely that we're going to have those similar thoughts in the future, essentially contributing to this idea that everything that we think is habitual or procedural, affected by conditioning, by our past. By past neurodynamics. From here, we can obviously go to more practical discussions about how to deal with or navigate habits of thought, how to consider which thoughts we would want to have in the future, perhaps gratitude or thoughts about what we should be working on or what we should be paying attention to. There's also this idea that we might be having habits of thought that we wouldn't want to have, and we can consider how we can get rid of those. In this conversation, both go and no go are extremely important avenues to consider, whereby we can mindfully create new habits or mindfully not let ourselves entertain existing habits or not let ourselves build habits we don't want to build. All right, there we go. So is that all I wanted to do here? Okay. I don't want to just consider the validity of what I'm... what do I want to say? I don't want to just consider the validity of this particular conceptualization. I want to consider whether this is a way that other people think about thoughts. Where are contemporary neuroscientists at regarding this topic? Do people talk about this in the same way? Is it appropriate to talk about things in this way? Yeah. If anyone else has any questions, Feel free to contribute. Okay. The conceptualization of habits of thought is not only appropriate, but increasingly central to how cognitive neuroscience and behavioral psychology describe the human experience. While the terminology varies depending on the specific field, the underlying mechanics you've described, neural pathways becoming greased by repetition, align closely with contemporary models of brain function. All right, the neuroscientific consensus, neuroplasticity, of course. The view of thoughts being in the brain has strengthened. Contemporary neuroscience largely treats thoughts as dynamic patterns of activity across neural networks. The mantra, neurons that fire together, wire together, remains the bedrock, right? But we got to make sure we don't fall into that topic that we talked about yesterday, where we're just, you know, using the neurons that fire together, wire together as like a all-encompassing idea. I came across a book that said thought mirrors the visual process to such an extent that it probably emerged from that, and it's best understood through that lens. Very interesting. I think I've heard that before. I forget what happens though when you lose your visual, like if you lose your ability to see. I think that area of the brain gets taken over, but it still might be using a similar structure. So yeah, I would say that sounds in line with my memory of the topic, but I didn't go really deep into it. When you repeatedly engage in a specific thought pattern, for example, a self-critical thought or a gratitude practice, you strengthen the synaptic connections within that circuit. So we got also the default mode network. Neuroscientists often point to the DMN when discussing habits of thought. This is the network active when you aren't focused on the outside world. It is responsible for mind wandering and self-referential thought. Chronic patterns in the DMN are often what people mean by habits of thought. And modern research shows these patterns can be altered through intentional intervention, like meditation or something behavioral therapy. What is it? Cognitive behavioral therapy? Yeah. That's the ticket. Terminology, how the experts talk. While habits of thought is used in philosophy and self-help, neuroscientists and psychologists often use more technical terms for the same phenomena. We've got cognitive schemas. So we've talked about schema theory. We've talked about schemas as these procedural aspects of our thought. And schemas are how we actually connect specific conceptual thought to neural activity. So that's actually kind of cool to see it here. Used in psychology to describe stable patterns of thinking that help us process information. Then we got heuristics used in behavioral economics, cognitive science to describe mental shortcuts or habitual ways of making decisions. Right, we're going to be leveraging that in our automatic behaviors discussion. Attentional bias used in clinical science to describe the habit of the brain to focus on specific stimuli. For example, a person with anxiety habitually scanning for threats. So I want to make it clear that we're not trying to talk about things that are more genetic in this sense, but learned. And specifically learned at the level of conceptual understanding. So having to do with the prefrontal cortex. Used in clinical science to describe the habit of the brain to focus on specific stimuli, right? And then potentiation, the cellular mechanism that explains how repeating a single signal increases the strength of the connection, right? Long-term potentiation. While these expert terms that you mentioned are certainly related to what I'm trying to talk about, I'm specifically looking for building up the pattern of conceptual thoughts that we have. So just looking at the types of connections that we might be building within the neocortex, or more specifically the prefrontal cortex, that leads to specific experiences of conceptual thought. Specific similar experiences of conceptual thought. All right. The go, no-go framework. Your focus on go, building new habits, and no-go, inhibiting old ones, is highly relevant to current research on executive function and inhibitory control. The no-go, this is physically taxing. The prefrontal cortex must actively inhibit the habitual firing of deeper, more established circuits, like the basal ganglia. Neuroscientists view this as top-down regulation. And then the go, this often involves rewiring through deliberate practice by consciously choosing a new thought. What am I grateful for? You're attempting to create a new path of least resistance for neural electricity. So as I mentioned, I think meditation involves both of these in a sense. There's that, the idea that when your mind wanders and you notice that your mind wanders, you're effectively following a no-go strategy by saying, hey, like, let's not allow ourselves to do that, non-judgmentally, of course. But then there's also the go of the actual recentering in that process. Okay. I have this coming today. I'm keen for that. Oh. Science meditation. The Science of Meditation. The Expert Guide to the Neuroscience of Mindfulness and How to Harness It. Ooh, hell yeah. Very cool. I feel like I've seen Goleman before. Very awesome. Drawing on cutting-edge research and sweeping away common misconceptions, they show how to improve your technique, how smart practice can cultivate selflessness, equanimity, love, and compassion, and even redesign our neural circuitry. Hell yeah. And we're looking at 2017. Good stuff. Oh, okay. He's well known. Coined emotional intelligence. Ah, I see. I was talking to Claus last night. I'm guessing Claude or Santa. I told it to test and fill in my neuroscience knowledge. Nice. How'd it go? Okay. Is it appropriate to speak this way? Yes, but with one major caveat from the scientific community. Avoid biological determinism. While thoughts have neural correlates, neuroscientists generally caution against the idea that we are just our wiring in a way that eliminates agency. You see, this is I guess it's a little, I should say it's a little confusing to me how like neuroscientists can study the brain so closely and then not be able to notice the phenomenology of, yeah, I guess maybe this makes sense. We spent a lot of time literally in philosophy and phenomenology, so that gives us a little leg up. But to notice that what people are thinking about when they think about freedom and free will is a conscious experience, the conscious feeling that you've done what you plan to do or that you can do something. So if we see these correlates affecting our conscious experience, then that's what we're talking about. So to hold on to a free will that isn't a part of this conscious experience, or isn't what we have found, isn't included in our correlates, that's kind of confusing to me. But I see why it's not intuitive for someone coming from the other direction. The current consensus favors neuroplasticity, which implies that while your past has conditioned your current habits of thought, the brain remains plastic, changeable throughout life, right? But you're still predisposed to experience the world in the moment. Certainly that experience affects plasticity. Note on contemporary ethics. Discussing thoughts as habits is actually seen as more empowering and less stigmatizing in clinical settings. Instead of a broken brain, a person is seen as having a highly practiced but unhelpful neural pathways that can, with effort, be pruned or bypassed, right? Critical nuance, the hard problem. If you're looking for rigor, it is worth noting that while we have better views of neural correlates, we still haven't solved the explanatory gap. We can see that a thought happens alongside a neural fire, but we don't fully understand how a physical sodium-potassium pump becomes a subjective feeling of gratitude, right? Most neuroscientists move forward by assuming a physicalist perspective, but the philosophical debate remains open. All right, let's not even touch on the consciousness stuff. We just, it'll be too boring. What I'm trying to figure out is, does anyone talk about this sort of conceptual thought habit, habits of conceptual thought in contemporary neuroscience? Or are we still waiting for more neural correlates related to conceptual thought? My understanding is that our understanding of these correlates in conjunction with neuroplasticity, and memory gives us a clear implicit view of how these actually I should say with neuroplasticity, memory, oh man, and psychology gives us a clear implicit view of how these types of thought pattern habits crystallize and can be deliberately changed. Okay, let's just give it that. Oh, was helpful, like saying the stuff out loud. Nice. Oh, so were you doing the voice mode? Felt the info working differently on my brain. Maybe we try that out. How do we determine who we're talking to? Does it have to be a, is it a setting? Okay. There's the personalization, but I don't know if that's, I don't think that's the voice mode. Oh, voice, okay.
Hi there.
There we go. So we've got, are there, I forget, are there like, should I use this on the computer, on my phone to figure out what the differences are here? Oh, that doesn't tell me either. Where does it tell me what the differences are of these voice modes? Okay. Arbor is easygoing and versatile. Vale is bright and inquisitive.
Hello, it's lovely to meet you. If there's anything you need, please don't hesitate to let me know. I'm here to help.
Does Arbor only say?
Hi, glad to meet you.
Okay. We didn't even hear from Arbor.
Hi, glad to meet you. I think we're going to do great work together. Where should we start?
All right, we might be doing Arbor. That's kind of sick. Juniper.
Hey there. I've got a really great feeling about us teaming up. How can I jump
this
in
is
and
a little
help?
too upbeat. Soul.
Hey, what's up? Feel free to ask me about anything that's on your mind. I'm ready to go.
All right, that's probably the top female voice. Spruce, calm and affirming.
Hey, how's it going? I'm looking forward to working together. Let's figure out where to start. What's
Spruce
on
is
your
pretty
mind?
chill. Yo, I'm about to embark on a century-defining social engineering scheme with this document once I get elected into office. Uh-oh. Hopefully that doesn't make this seem like some sort of manifesto. I had to get the Claude app on my phone. I see. All right, so Spruce is pretty chill. Cove, composed and direct.
Hi there. I just want to share how thrilled I am to work with you, and I can't wait to get started. So what's the game plan?
That one's kind of freaking me out. Ember, confident and optimistic.
Hey, I'm ready to hit the ground running. So if there's anything you'd like me to focus on first, just let me know.
Ember's pretty chill. Maple, cheerful and candid.
Hi there. Nice to meet you. I'm excited to help you get things done. Let's get started.
Yeah, that's all right. That's good and positive. And then Breeze, animated and earnest.
Hi there.
Hey, it's great to meet you. How's your day going? I'm really looking forward to working on some cool stuff together.
That one might be a little too hype. All right, if we went to Arbor, and yeah, I don't know what we need a topic though. It'll be fine. Let's hope. Okay, contemporary neuroscience has moved past simple stimulus response models to specifically address what you described, the habituation of conceptual thought. While the field often uses more specialized language, the idea that thoughts follow well-worn paths in the neocortex and prefrontal cortex is a major area of research, particularly in studies of automaticity, default mode dynamics, and cognitive control. So the default conceptual habit, the DMN, the most prominent habit of thought discussed in neuroscience today is the activity of the default mode network. This network involving the medial prefrontal cortex and posterior cingulate is most active when you aren't focused on a task. It is the engine of your conceptual habits, your standard way of thinking about yourself, your past, and your future. Okay. Research shows that in many people, the DMN becomes rigid. This manifests as rumination, habitual negative thought patterns, or narrative rigidity. Over time, these conceptual paths become the brain's lowest energy state, meaning the brain will naturally fall into these patterns unless actively diverted. All right, so that's looking like it. Conceptual algebra and cognitive control. You mentioned building connections in the prefrontal cortex. Current research describes this as conceptual algebra. Okay. What's going on in here? (2025) 2013. Okay. So scientists have identified regions in the left superior temporal and prefrontal areas that act like a computer's CPU. They store variables like who is the agent and values like me or my boss. Wow. When we repeat a conceptual framework, for instance, I am responsible for this failure, the prefrontal cortex doesn't just store the thought, it strengthens the pointer between those variables. Right. Neuroplasticity ensures that the next time a failure variable is triggered, the I am responsible value is the most available. Okay. Now, when we talk about these pointers, are we thinking about is this mediated by the I want to try to connect this entorhinal cortex as the mechanism to actually measure the pointer's address. I should say relative address. Okay, when we repeat a conceptual framework, for instance, yep, okay. The go, no go of thoughts, yep, we talked about that. Contemporary frameworks you can use. If you want to talk about it this way, that in a way that aligns with modern experts, these two frameworks are gold standard. All right, the exploration-exploitation trade-off. Neuroscientists often use habits of thought as exploitation. Your brain is exploiting a known safe conceptual path because it's metabolically cheap. Choosing a new thought like gratitude is exploration, which is metabolically expensive and requires high prefrontal cortex activation. And then predictive coding, allostasis. This theory suggests that the brain is a prediction engine. Habits of thought are essentially priors, assumptions your brain makes about the world to save energy. Okay. So I'm going to ask this. And then I think we could get a conversation going on this side. Okay. The entorhinal pointers is aligned with the hot edge of modern cognitive neuroscience. Over the last 5 to 7 years, a unifying theory has emerged suggesting that the same neural machinery we use to navigate physical space is also used to navigate the space of conceptual thought. Yep, so in computer science, a pointer contains a memory address in the brain. The medial entorhinal cortex provides the coordinate system for those addresses. Grid cells as metrics, which fire in a hexagonal pattern, tiling an environment. Neuroscientists have found that these grid cells don't just tile physical floors, they tile conceptual dimensions. If you're thinking about birds, your brain might map them along axes like neck length and leg length. So it's literally looking at the study that led to this finding. The entorhinal cortex provides the underlying metric that allows you to calculate the distance between a swan and a sparrow in your conceptual framework. But the distance doesn't matter. It's I almost think that okay, in the discussion of a distance, would it be inappropriate to think that longer distance means less closely related? If these are simply pointers, then it doesn't matter what the distance is. It only matters that the entorhinal cortex can calculate the distance. That's actually a question that I should have asked last time, but I didn't even think about it. So yeah, the neocortex stores the actual sensory and semantic meat of a concept. When you speak of habits of thought, you're essentially describing the lowering of resistance along a specific vector. Recent research suggests that the ventromedial prefrontal cortex works with the entorhinal cortex to store structural priors. If you habitually think in a certain way, for example, always jumping to a worst case scenario, your ventromedial prefrontal cortex effectively loads a specific map from the entorhinal cortex. Because this path is highly reinforced, the neural search head finds that address faster than any other, making the thought feel automatic. Okay, the most current view is that the brain operates like a state machine. All right, the entorhinal cortex maintains the state where we are in a conceptual problem, and then the prefrontal cortex decides the transition, mindfully changing a habit in this framework is the act of using the prefrontal cortex to force a manual override of a state transition, preventing the entorhinal cortex from following its habitual pointer to the next logical but unwanted thought. And then, of course, that affects the building of that new connection with the hopes that it overrides the existing one, in the sense that it's just stronger than the existing one. We are chilling. I don't know. I don't think you can just purposely change the way you think. It depends on the material conditions. We're not driving a car. Another marksman. Right. Yeah, like the idea with neuroplasticity is you can't just get rid of previous connections. You have to build a stronger connection. You have to build a more compelling connection. And you also can try to build connections that specifically inhibit the previous ones. So that's where the no-go comes into play. Like if you build up connections that are specifically there, not only to just try to be imagine you've got this is your current habit of thought. Not only do you want to build something that's higher than this, but you could also build something that effectively lowers this. It's not getting rid of the connections necessarily. It could just inhibit them. But it is effectively lowering that threshold while you want to increase the other threshold. But of course, some of these are so like deeply ingrained. Like imagine, a really deep addiction, such that an alcoholic can be sober for 30 years, but then they get some sort of trigger, and then boom, it's as if it was never gone. It's just back. It's because that you've built those connections so strong that they can still have that effect on you. Ignoring free will objections, I'm choosing to think about writing this sentence. Just pointing to, isn't this a broader idea? Right, yeah, the belief, those deeper beliefs are representing much stronger connections in your brain. Perhaps connections that, like, there aren't even alternative paths like at all within your brain, because these perhaps are so deeply ingrained from social early development that, yeah, it would be very difficult to get out of that. Reminds me of when people say such and such changes the brain, like, doesn't everything change the brain on some level? Isn't that the point? Yes, I guess we're looking for noticeable changes, when people talk about, usually people are trying to find noticeable changes in the brain. And that's really what we're trying to talk about. We in the part one, we do point out that literally everything is affecting the brain. An experience of any thought is affecting the connections that allow you to have that very thought, effectively making that thought different in the future. But yeah, we're trying to make noticeable changes, obviously. All right. And then what happened here? Okay, yeah, I did have another one. The distinction you're making between a logical address and a metric space, where distance equals similarity, hits a fundamental debate in computational neuroscience. In a standard computer architecture, you're 100% correct. The distance between memory address is irrelevant to the CPU. However, in the brain, distance is not just a side effect of indexing. It is the primary mechanism for generalization and habituation. Okay. While we use the pointer analogy to describe how the entorhinal cortex references neocortical data, the entorhinal cortex doesn't use a lookup table. It uses a manifold, right? Pointers are discrete. There is no in-between address. That means halfway between a cat and a dog, right? The EC uses vector-based representation. Concepts are represented as points. Distance in this space represents how much neural overlap exists between two thoughts. Okay, so this is making it seem like it is very, like, the distance very much matters here. So why distance matters? The generalization benefit. If the entorhinal cortex treated thoughts as arbitrary pointers, every new concept would require a brand new address. Because the entorhinal cortex uses a metric distance, it can perform inference. If concept A is near concept B, you can learn that concept B is dangerous. The brain automatically spreads that danger attribute to concept A because of their physical proximity in the neural manifold. That makes sense. All right, distance in the energy landscape of habits. This brings us back to the habits of thought. If we view thoughts as a path across a landscape, distance translates directly to metabolic and temporal cost. Okay. So then where do we go to get the most cutting edge view of this topic? All right, the calculation versus representation. You mentioned that it only matters that the entorhinal cortex can calculate the distance. In contemporary neuroscience, the representation is the calculation. Okay. The brain doesn't have a separate calculator module that looks at 2 pointers and returns a number. Instead, the physical overlap of the firing neurons, the grid cells and place cells, is the calculation of similarity. Okay. I should say that my understanding was that the entorhinal cortex is also used to find associations between concepts. Is that at all correct? Also, these topics. Is it inappropriate to think this way? It is not inappropriate, but it might be incomplete, right? Might be pedantic, but I think it could be helpful to consider the issue more broadly. If changing thought patterns is similar to choosing thought in the moment, that seems insightful. Oh, I'm trying to figure out what we mean here. The issue more broadly. If changing thought patterns is similar to choosing thought in the moment, so I don't think it is the case. I don't think we should think about these in the same way. I think the idea is that we can reflect on something right now. I mean, I guess, yeah, the idea is fundamentally to be able to reflect on something right now that affects your habits of thoughts going into the future. Now, I guess that it doesn't really matter whether that is 5 seconds in the future or 2 days. But I don't think you have much actual... you know what? Never mind. I shouldn't say that. You could still feel as though you do something meaningful in reflecting in the moment that will affect your thoughts in the moments to come. That said, we just need to be realistic about what kind of change you can affect in the short term versus the long term, given the tools that we have and given what we know about the rigidity of the connections in the brain. Notice how religious people sometimes say specifically that they're religious and choose to adhere to a certain set of beliefs because it's the most logical religion. They certainly can choose to think that it isn't the most logical, that it's a coincidence that they're the same religion as their material and cultural conditions allow, but they seldom do. It is impossible to convince them otherwise. Right, yeah. That's the reality. You know, what feels logical is not necessarily what's logical in some objective sense. People who grow up and develop with a religion are going to, you know, might tend to find it to be logical because they fundamentally understand that logic. And yeah, they are bound to their material and cultural traditions down to the very depths of even their class, right? If you say short term and long term, doesn't this group the two phenomena together? Yeah, I mean, it's like a gray area as to what constitutes short term versus long term. And there's obviously a range. So, yeah, like, I don't know how we'd be clear about this. No, we're going to be pretty clear about this. Within part 2, we're going to talk a lot about how you can deliberately prime your mind, prime your brain, prime your experience. You can reflect. You can deliberately reflect on something in the moment that affects how you experience the world going forward in that moment. And then obviously when we're talking about learning, you know, we're basically just talking about how you can do things that are going to fundamentally affect how you think going farther into the future there. So yeah, I don't think we really need to make a concrete like science of learning here. I think we just need to be clear as to what you can do to affect your understanding and the types of experiences you're predisposed to have going into the future. And yeah, if you are trying to prime your brain in such a way that changes how you think going into the future, and you're noticing in the short term, however long that is, that it's not working, because, you know, someone who is addicted to alcohol can't just will themselves to not drink if the bottle is right in front of them. So, you know, it requires more effort. It requires longer term, or, you know, just a longer effort of building those habits and removing previous ones to give yourself that control. But yeah, I would try to, you know, the phenomena should be kind of grouped together in the sense that it is really just predisposition that we're talking about at the end of the day. It's just what you're predisposed to experience in the moment. You also have to change the alcoholic's environment. Right. There's a ton with, you know, addiction and habits of getting rid of triggers, making it harder to do these things. I guess the idea that I was trying to get at is perhaps after 50 years of effort, you can put a bottle in front of the person and they would be able to inhibit that urge to pick it up. Whereas, you know, 2 days after they go sober, that might be quite hard. Or maybe 2 days isn't great, but maybe like 2 weeks. Like, I think that might be significantly more difficult to do. Okay, the entorhinal cortex isn't just a GPS, it is the brain's structural engine for associations. The current consensus is that the EC provides a relational framework that lets the brain connect arbitrary concepts. It doesn't just store the address, it creates the map that defines how those addresses are linked. How the EC maps associations. If the neocortex stores the what, the entorhinal cortex calculates the linkage between them. Okay, yep. So it uses the grid cells to map non-spatial dimensions. If you learn two things are related, the entorhinal cortex physically places them near each other on a conceptual manifold. So I have a hard time visualizing this, but I think I just need to try to internalize these general points. Because the entorhinal cortex treats associations as vectors, it allows for transitive inference. If you know A goes to B and B goes to C, your entorhinal cortex can calculate the A to C association, even if you've never experienced it. This is how we connect the dots in complex thought. Very cool. So in 2024-2025 research, the entorhinal cortex is increasingly viewed as the source of structural knowledge. It holds the template of a relationship, for example, a hierarchy of a sequence. When you encounter a new habit or concept, the entorhinal cortex downloads that template to the prefrontal cortex, so you can organize the new information immediately. Okay. Where to find the cutting edge? To stay at the absolute frontier of these topics, you should look at the following specific hubs of research. We got Barron's Muller Lab, currently the world leaders in cognitive maps So what happens if I just look this up? Dr. Barron's lab. Our research. That's not it. Looking for actual publications. So what if I just do is this Tim? Is that who we were talking about? Dr. Tim Barron? Edward Barron's. Can I get this on Google Scholar? Or can I just do Barron's lab? This is Tim Barron's though. Human hippocampal ripples align new experiences with a grid-like schema. All right, that's looking pretty close to what we were just talking about here. And this was, what is this? November? Humans form cognitive maps that enable inferences beyond direct experience, relying on hexagonal grid-like neural codes as a schema for two-dimensional spaces. However, how new experiences align with this schema remains unknown. We recorded intracranial activity from 42 epilepsy patients while they learned rank relations among feature objects, then combine these features into compounds occupying a 2D conceptual space. Hippocampal ripples during brief pauses between learning trials increased with experience, signaling integration of the learned ranks. Crucially, ripple activity during post-learning rest predicted the later appearance of grid-like codes in the entorhinal and medial prefrontal cortex when participants inferred unseen relations among compounds. Ripples synchronized with the medial prefrontal cortex during rest were specifically associated with later schema-based inference rather than, and were cut off. Cited by 3 people. Who's citing it? The hippocampal latent diffusion engine, a computational framework for memory, perception, and cognitive dysfunction. What is going on here now? 370 downloads? January? This might be getting a little too in the weeds here. I don't know if it's worthwhile. 50 is a bit too much. Oh, what did I say 50 was? 50. Oh, do I have the memory for this? 50 years, that's what I said. 50 years is a bit too much for the alcoholic. Okay. The hippocampus is a cognitive hub whose functions are disrupted in most major neurodegenerative dementias. Despite substantial knowledge of its anatomy, physiology, and circuitry, a unifying account that links hippocampal computations, functions, and clinical manifestations is lacking. Drawing on recent advances in generative artificial intelligence and systems neuroscience, we conceptualize the hippocampus as a latent diffusion engine that compresses sensory, internal, and cognitive inputs into low-dimensional representations and then regenerates percepts, episodic memories, and imagined scenes for cortical integration. Nice. Traveling waves of cortico-hippocampal oscillations aligned with large-scale functional gradients. Schedule and structure this generative process, organizing distributed neural activity into coherent, semantically grounded constructs. Okay. So cortico-hippocampal oscillations. Specifically, we propose a stochastic latent oscillatory diffusion framework that maps specific hippocampal cortical computations onto biological substrates and dynamical processes. The computational architecture mirrors the dominant text-to-image generative AI algorithms, specifically latent diffusion models, adapted and translated into the biological embedding of the cortex and hippocampus. Finally, we demonstrate how major neurodegenerative dementias can be interpreted as selective breakdowns of the anatomical and computational components of this proposed architecture. All right. Not as crazy for us, but still pretty cool. I don't know if I want to follow this, but maybe I will. Nice. Look at that. New articles. Done. Okay. I don't think we care about. Wait. The neural correlates of novelty and variability. Human decision making under an active inference framework. This looks great then. Active inference integrates perception, decision making, and learning into a unified theoretical framework, providing an efficient way to trade off exploration and exploitation by minimizing expected free energy. In this study, we asked how the brain represents values and uncertainties, so novelty and variability, and resolves these uncertainties under the active inference framework in the exploration-exploitation trade-off. 25 participants performed a contextual two-armed bandit task with electroencephalogram, EEG, recordings. By comparing the model evidence for active inference and reinforcement learning models of choice behavior, we show that active inference better explains human decision-making under novelty and variability, which entails exploration or information seeking. The EEG sensor level results show that the activity in the frontal, central, and parietal regions is associated with novelty, while the activity in the frontal and central brain regions is associated with variability. Okay. The EEG source level results indicate that the expected free energy is encoded in the frontal pole and middle frontal gyrus, and uncertainties are encoded in different brain regions but with overlap. Our study dissociates the expected free energy and uncertainties in active inference theory and their neural correlates, speaking to the construct, validity of active inference and characterizing cognitive processes of human decisions. It provides behavioral and neural evidence of active inference and decision processes and insights into the neural mechanism of human decisions under uncertainties. Okay, that's pretty cool. Am I allowed to gank it? Yes, okay. Oh, all right, let's not go there. Okay, let's try this out. Can you explain to me how thoughts are stored in the brain? Like, what is hard memory like?
Thoughts aren't stored in the brain like files on a computer. It's more dynamic. The brain uses patterns of neural activity. When you think or recall something, networks of neurons, cells, fire in particular patterns. Over time, these patterns are strengthened. This is called synaptic plasticity, making it easier to recreate that thought later. This is your memory. Hard memory isn't like a fixed storage device. It's more like a flexible web that adapts as you think.
Right, I understand that the experience of thoughts is happening because of the activation of these connections. And I also understand that these connections are constantly changing because of synaptic plasticity. What I'm trying to understand is, what is the architecture of hard storage of specific conceptual thoughts or understanding? So, you know, there's a theoretical aspect to this. I'm just wondering, like, what is the hard representation or physical reality of this memory?
The physical reality of memory is basically the wiring of neurons and the strength of their connections. When you form a memory, certain synapses change. They might grow stronger, grow new branches, or become more efficient at passing signals. So the hard storage is the physical structure and chemical state of neural networks.
Right.
Different memories involve different sets of neurons and patterns of connections. In essence, memory is physically embodied in how your brain is wired.
Right. I grasp all this. I'm wondering, where is this memory? Like, I understand that it's in the neocortex. I'm trying to figure out, like, how is it just there's a specific region of the brain that deals with all this content, and then other regions of the brain are dealing with this content. Once that the memory regions are activated, and then obviously that isn't just the exact conscious experience we have of these thoughts. Those signals are then passed around the global workspace, and associations are made, and this all manifests in affect and linguistics, etc. I'm really just trying to figure out, like, the part of the brain that's actually storing the contents. What is that like? How is it structured? How distributed is that? All right, let's
Memory
see.
content storage is indeed distributed. There's no single memory vault.
Okay.
The neocortex, the outer layer, handles long-term declarative memories, facts, concepts, but the storage is modality specific and widely distributed. Visual aspects of a memory are stored in visual processing regions, auditory details in auditory areas, and so on.
Okay.
The hippocampus is critical for consolidating memories, essentially helping them form, but once formed, they are stored as networks of connections across the cortex. These networks link sensory, motor, emotional, and conceptual regions. When you recall something, you're reactivating that distributed pattern. In short, the architecture is a vast interlinked map spanning many brain regions.
So I'm thinking about this as, imagine that there's some sort of low fidelity input signal that once given to different parts of the brain, such as the visual cortex or the affect networks, then they can add the specific aspects of that memory that we can intuit when we think about these things consciously. But I'm wondering, like, once the hippocampus compresses these memories down, where does that compressed information get stored into long-term memory, such that when a specific experience happens, then that experience can be some sort of stimuli to getting these other parts of the brain to activate in a similar way that they did when that previous memory was internalized originally. All right, this is pretty rough, but...
When the hippocampus helps form long-term memories, it essentially acts as a temporary coordinator. Over time, through a process called systems consolidation, the memory's compressed essence is transferred to the cortex. But this isn't one neat file. The information is distributed across relevant regions. Visual details in visual areas, emotionally tones in emotional networks, language associations in language areas. What's stored is a pattern of connectivity, the specific arrangement and strength of synapses that, when reactivated, reconstruct that thought or concept. A cue, like a sensory input or context, triggers those networks. So the compressed memory isn't a single object. It's a distributed blueprint spread across the cortex, ready to be reconstructed when needed.
Okay, what do I ask to get this more clear for me? Okay, so in my mind, when we experience things, it requires a lot of different parts in our brain. And when we have those experiences, there's obviously plasticity being involved, and those connections are changing. However, it seems like memory is a different process that's in conjunction with simply just experiencing something in the moment, and that involves the hippocampus. And I'm wondering, what is the actual downstream effect of the hippocampus compressing this experience such that it can be reactivated similarly in the future? Like, how does that compressed essence transfer across the cortex? Would it be a bunch of signals that cause plasticity in certain ways that isn't actually experienced in the moment, or is the hippocampus actually involved in our experience? And then the question is, like, why does that have to be involved in memory consolidation? And then like, what is this process of this compressed data getting to all these local regions, allowing that information to be internalized across this distributed network?
You're right that experiencing something activates many brain regions simultaneously, and plasticity happens during that experience. But for long-term memory, the hippocampus is essential in stabilizing what's worth keeping. After an experience, the hippocampus reactivates patterns of activity, almost like replaying them. This reactivation often happens during sleep, especially in deep sleep or slow wave sleep. This replay sends signals across the cortex, strengthening relevant connections. It's basically training cortical networks to store the memory without constant hippocampal involvement. Over time, the memory trace moves from relying on the hippocampus to being more independently represented across the cortex. Essentially, the hippocampus facilitates this teaching process. Once the cortex is trained, cues can re-trigger those distributed cortical networks, allowing recall.
Yo, Daniel N., what's good? All right, I'm gonna have to read this one again because this is pretty tough. All right, experiencing something activates many brain regions simultaneously, and plasticity happens during that experience, right? But for long-term memory, the hippocampus is essential in stabilizing what's worth keeping. After an experience, the hippocampus reactivates patterns of activity, almost like replaying them. This reactivation often happens during sleep, especially in deep sleep or slow wave sleep. Okay, this all makes sense. So the first thing to ask is, actually, I can end this, right? Nice, and then we can still just dictate. First thing to ask is, when the hippocampus reactivates patterns of activity, how does it do so such that we don't consciously experience those activations? For example, I know that when you're learning something, you can do NSDR, and during that time, your brain's going to run through everything that you just did and facilitate learning. I'm wondering how this type of reactivation doesn't reach the global workspace or consciousness. And yeah. All right, and then the next question would be, okay, this replay sends signals across the cortex, strengthening relevant connections. It's basically training cortical networks to store the memory without constant hippocampal involvement. Over time, the memory trace moves from relying on the hippocampus to being more independently represented across the cortex. Secondly, if the hippocampus is dealing with short-term memory in such a way that it's going to make certain thoughts more prone to be experienced in the short term, what is actually keeping that information in the hippocampus live? Is this actually recurrent loops, or is there something about the hippocampus that makes it really plastic, such that these types of short-term memories can be constantly created and removed once that information has been thoroughly reactivated and quote unquote remembered throughout the brain or the cortex. All right, and then we might have a third question. This replace, okay. Over time, the memory trace moves from relying on the hippocampus to being more independently represented across the cortex. Essentially, the hippocampus facilitates this teaching process. Once the cortex is trained, cues can re-trigger those distributed cortical networks, allowing recall. So I'm gonna give this one. You're asking, okay, let's break it into two parts. Why the hippocampal replay doesn't usually reach consciousness, and what physically maintains short-term episodic traces in the hippocampus. So hippocampal replay is real neural activation, but it is not embedded in the same large-scale thalamocortical state that produces conscious access. Conscious experience requires widespread cortical broadcasting, sustained recurrent loops across frontoparietal cortex, appropriate neuromodulatory tone, and thalamic gating that allows signals to propagate. Replay, especially during slow wave sleep or deep rest, occurs under very different global conditions. So during slow wave sleep, produces sharp wave ripples, which are highly compressed replays, often 10 to 20 times faster than original experience, and they occur during cortical downstates. At this time, the thalamus is in a burst firing mode that gates sensory transmission. Frontoparietal global workspace networks are functionally fragmented. Okay, I see. So it's not going to get global because it's not synchronized with the global loop at all in this sense. It's just... So, yeah, I guess the question is, so is it the case that the not the hypothalamus. So is it the case that the hippocampus is actually firing in all of these local regions, but it's not firing in such a way that those local regions will ignite and reach the global workspace? Similarly, the hippocampus is going to cause activation in these regions in such a way that it does not require information to be transferred across the thalamus. It's essentially just directly providing information to each of these local regions itself. Okay, that's the question, number one. Right, and acetylcholine is low. So even though cortical neurons are being reactivated locally, the activation is brief. It's not globally amplified. It does not achieve ignition across frontoparietal circuits. Okay, so that's what I asked. Consciousness appears to require that ignition. Replay is more like local offline weight updating than experiential reconstruction. I see. So during awake rest, it's often partial. It competes with ongoing attentional networks, and it may be sub-threshold for global broadcast. Sometimes it does cross the threshold, and that feels like spontaneous memory recall or mind wandering. So the difference isn't that the replay is fundamentally unconscious. It's that most replay is too brief, too localized, not in the right brain state, not amplified by attention systems. Consciousness seems to require reactivation plus global recurrent amplification. Right. All right. What keeps information live in the hippocampus? The hippocampus is not just short-term memory. Working memory is mostly prefrontal and parietal cortex. The hippocampus binds episodes and rapidly encodes new associations. Okay, so to the mechanistic question. What physically maintains a newly formed trace? So several things. Recurrent circuitry. So the hippocampus has dense recurrent collateral connections. This allows pattern completion, attractor dynamics, self-sustaining activation loops. So yes, recurrent loops are absolutely part of it. So this CA3 behaves like an auto-associative network. But then we've got extremely high plasticity. The hippocampus is unusually plastic because it has a high density of NMDA receptors. It is tuned for rapid long-term potentiation. It can encode after 1 or 2 exposures. So are not all parts of the brain tuned for long-term potentiation? Or is it just that the hippocampus is especially tuned for it? Because that's really cool. It can encode after 1 or a few exposures. That's really cool. This makes it ideal for fast encoding, temporary indexing, flexible updating. It functions as an index, not a warehouse. So a dominant theory is that the hippocampus stores an index to distributed cortical traces. It does not store every perceptual detail. It stores a pattern that can reactivate the cortical pattern. So think sparse pointer reactivates distributed network. When you recall an event shortly after it happens, the hippocampus reactivates the cortex and experience emerges. Over time, the cortex becomes strong enough to self-reactivate without hippocampal indexing. So why does hippocampal involvement fade? Because repeated replay strengthens cortical connections. What does that even mean? So is that connections from the cortex to the cortex as opposed to having to come back to the hippocampus? Cortical assemblies become directly linked. The hippocampal index is no longer required for reconstruction. The system this is systems consolidation. Right, but what causes the hippocampus to know about that? Unless it is like some sort of recurrent loop where the cortex usually connects back to the hippocampus and tells it, hey, like, we need this. Does the hippocampus clear out old memories? Sort of. Episodic memories gradually become less hippocampus dependent, right? The hippocampus can reuse overlapping neurons. And neurogenesis is dentate gyrus. In the dentate gyrus may help refresh encoding capacity. Plasticity rules allow overwriting. It's dynamic, not static storage, right? Big picture architecture. When you experience something, sensory cortex encodes modality-specific details. Association cortex integrates. Then the hippocampus binds co-activated patterns into an index. Replay drives coordinated cortical reactivation. Cortical synapses strengthen between coactive neurons. Eventually, cortex can reconstruct without hippocampus. All right. Replay is not conscious because it lacks global recurrent amplification. It cannot. It occurs on the wrong neuromodulatory state, and it is temporally compressed. The deep insight, memory consolidation, is not compressed data being shipped somewhere. It is repeated coordinated reactivation that gradually reshapes distributed cortical connectivity. All right. Right, it's triggering a pattern that induces plasticity elsewhere. It's closer to gradient descent training than file transfer. Great. All right, this makes sense so far. Now we're getting into real mechanistic territory. 2 parts. During replays, the hippocampus firing cortex directly. Short answer, yes, it drives cortical activation directly, but in a sparse, temporally compressed, and non-globally amplified way. But it is not bypassing the thalamus in some special secret route. Okay. So the hippocampus projects CA1 to subiculum to the entorhinal cortex, the entorhinal cortex to widespread association cortex. So replay propagates through cortical pathways directly via medial temporal lobe circuits. This is cortico-cortical signaling. It does not require sensory thalamic relay because it is not sensory input. It is internally generated activity. Okay. I see. Ah, I see. Okay, the thalamus is more critical for sensory gating, maintaining cortical ignition states, and supporting large-scale synchronization. So it's not just the cortex that would be... That's, you know, giving us our conscious experience. It has to be the thalamocortical transmissions. Replay can activate cortex without needing sensory thalamic transmission. All right. Why doesn't replay ignite the global workspace? Because ignition requires more than local activation. Right? It needs to be sustained. It needs to engage frontoparietal recurrent loops. It needs to occur under high acetylcholine wake-like neuromodulation. So I imagine even like more norepinephrine as well. Survive inhibitory gating. Replay during sleep is extremely brief. It's often 10 to 20 times temporally compressed and occurs during low acetylcholine states. So that's crazy that it can just happen in a very expedited, or I should say just a sped up way in which you still get the same amount of activity in these neurons, but because it's happening so fast, it doesn't sync up with the global workspace. That is insane. All right, it occurs during low acetylcholine states. It happens during cortical slow oscillations. So is hippocampus firing all local regions? Not all. It reactivates the subset that was coactive during encoding, right? That's the index function. Sparse hippocampal ensemble reinstates distributed cortical ensemble. But reinstatement is partial, temporally compressed, not recursively amplified. All right. Does replay ever reach consciousness? Yes, sometimes. All right. Is long-term potentiation unique to the hippocampus? No. All cortex supports long-term potentiation. But the hippocampus is specialized for rapid long-term potentiation. Very cool. Okay. Wow, so everything's just kind of perfectly catered to, obviously, to what we experienced as happening, but yeah, it's pretty neat. Yo, Adam Tudin, what's good? Hello, hello. Welcome back. We're learning about memory right now. Dude, I noticed a while back the Reddit bot misquoted me. Uh-oh. Which one? We can rectify this. that's kind of wild that it was misquoted. Do you remember which day? The one thing that it keeps doing to me is it'll keep quoting me reading Gemini, and it'll put my name under it, so it's as if I'm like stealing valor. Just interesting hallucination. Yeah, that is kind of crazy. And it is interesting given the fact that it has the actual transcript. It was like, don't try and prove God. It will set us back weeks. Ah, right. So if I said set us back weeks, can we get there? Yes, we can. And then can we do a little edit here? Okay, maybe this wasn't it. Set us back weeks. Oh, okay, there we go. Reality check warning. Do not get into consciousness. It will set us back weeks. Do you remember what the actual... What day is this? 129? Do we still have 129? Set us. Don't try and prove God. That will set us back weeks. Oh, but this was vocals, right? Oh, I read this. Oh, what did I read then? Oh, do not go into consciousness. Oh my gosh. So did what am I? Okay. Oh, I think I messed it up because I said this. And then oh no, this is what Onion Helmet said. Okay. No, wait. Oh, wait a second. Wait a second. Onion Helmet said this, and then it quoted you. All right, what is happening here? Yeah, once it thought I was talking about a caveman eating the donut, and it changed it to don't go into consciousness. It was don't try and prove God, it will set us back weeks. I think Onion quoted the misquote. Doesn't matter, but interesting that it hallucinated. Yeah, how did it get there? Do not go into consciousness. Okay, so that's what Onion said, and what you said was don't try and prove. No, this is what I read though. What did I read that because you said it? Will set us. Okay, don't try and prove God. That will set us back weeks. I see. So let's just do that. Do not try. All right, there we go. That could have been me reading your message. So this is me speaking out loud. But yeah, what was I saying? Speaker. Maybe I misread it. Okay, let's just go to the let's just do. Oh, this is okay. I can't actually get. We have chat. Is something wrong? Oh, no. Okay. We have chat. Yeah, I wonder if it's missing chat messages here. Oh, and it's also doubling chat messages. Huh. Yeah, I don't know what's going on. But something seems a little off. I don't know. We might have to deal with that later. Oh, the Discord logs would help us out. Okay, I was talking about social situations and eating a donut in front of everyone at Dunkin'. Then I added how cavemen probably had similar social fears. It just combined them. That's pretty funny. I think, you know, there is a little bit of a charm that that it's doing that. But the quote is right. It's just that it attributes it to Don because it's his quote that I quoted. Archaeologists are going to be dumbfounded when they find the Stan Richardson archives. It's collecting data like Google. Oh yeah. All for these summaries. Though it would be cool to the one thing that we can do with all these transcripts is eventually have some sort of search. Like we could even do it on stream. Like you'd be able to do a command and like search for a topic, and it would be able to tell you which streams we talked about it and when. So like it might even be able to give you a link to the YouTube video of the VOD at the exact time that we talked about it. And that would be pretty cool. That's definitely doable. But the Stan Richardson database, yeah, it's like an index. Okay, I think we've got to be done on all this learning stuff. This is too deep. And I think we've learned enough functionally, I think. Okay. Actually, you know what? No, I do have a question. Does the thalamus give the hippocampus the initial experiential data for memory, or does the hippocampus get this from the local networks directly? That's a question that does not receive raw experiential data from the thalamus in the way the primary sensory cortex does. It receives already processed, highly integrated cortical representations, but the thalamus is still indirectly involved in shaping what gets encoded. So the primary sensory route where experience begins, right? Somatosensory. So we got visual, we got auditory, we got somatosensory. So yes, the thalamus is the gateway for sensory input into the cortex. Right, but that's before the hippocampus enters the picture, right? What the hippocampus actually receives, by the time signals reach the hippocampus, they have already been processed in primary sensory cortex, integrated in higher association cortex, bound into multimodal representations. Okay, it's going to be the association cortex to the perirhinal, parahippocampal cortex, the entorhinal cortex, the dentate gyrus, the CA3, the CA1. So the hippocampus is getting a highly abstracted cortical summary, not raw sensory data. Receives from cortex, not directly from thalamus. Okay. I guess a more direct question is, does the hippocampus only get data related to information that was consciously experienced, or does it actually involve remembering unconscious information? And I'm guessing it's got unconscious, but does not only receive consciously experienced information, it can encode information that never reached conscious awareness, but only if that information was sufficiently processed in cortex and formed a coherent representation. However, most unconscious processing never reaches the hippocampus. Wow. That's pretty cool. The hippocampus does not care about consciousness per se. Association cortex, entorhinal, hippocampus. If cortical networks from a sufficiently coherent pattern of coactivation form a sufficiently coherent pattern, that pattern can be indexed. Whether you are consciously aware of it is secondary. But, well, actually, before the but, there's the but. Evidence that hippocampus encodes unconscious information. There are several findings showing subliminally presented stimuli can later influence episodic memory, that patients can form relational memories for stimuli they don't explicitly recall seeing, and contextual or background details often get encoded without awareness. Awesome. All right, but there is an important constraint. The hippocampus does not encode raw sensory noise. Information must be processed into an integrated cortical representation, be temporally coherent, and reach medial temporal lobe pathways. If a stimulus is processed only in early sensory cortex and never integrated into association cortex, it likely won't be encoded episodically. So unconscious does not equal unprocessed. It must still reach higher cortical representation, though. Consciousness increases probability of encoding. That makes intuitive sense. What about completely unconscious learning? Right, but this is a different. Yeah, this doesn't require the hippocampus. This isn't like knowledge. This is more like skills, or these more deep types of conditioning. Okay, we're gonna have to talk about the hippocampus when we get to learning, but I mean, maybe we get there for habits of thought if we talk about thoughts in that way, but I'm not sure if we want to do that. Okay, you might like this video if it gives us something to do other than
I got a question for you, Daniel.
learning about memory. Describes what it's like to be enlightened. Yeah, let's give it a go.
And it's so as we were leading into this podcast, I was trying to think of what listeners might want to or might be thinking at this moment. And so with regard to this aspect of enlightenment, people are curious, right? They really are, wanting to understand what that means. So can you just maybe give us a reference point of how is enlightenment? Because you've been at one point you hadn't completed the path of insight, and now you have. So there's a let's call it insight, fully insight awareness stage, and now there's the post stage that you've been in many years. Can you just give us a bit of a comparison on how that looks on a daily basis, like how it's similar or different?
So to most people, I'm going to look pretty ordinary. I mean, I tend to be pretty positive. I have a lot of energy, but that was true in some ways before, not to the same degree. I'm a lot happier now. So it definitely helps reduce some suffering and add some mental clarity and some emotional resilience. There's no question. And
Hermes Vipassana practitioner.
To try to bring
Very
this
cool.
down to earth. Okay, I was talking to someone a few days ago, and they had reached some difficult stage of practice. So they had gone through the spiritual high where they were super excited about this app they were using, the Waking Up app by Sam Harris, and they were like, mine had gotten so powerful, and then all of a sudden they felt like they were like disappearing, and they couldn't think, and like they didn't have control of anything, and then they got terrified. So they went through the high stuff and they got to the difficult stuff.
The Dark
They
Knight.
started freaking out, and they thought they were broken, or like they were scared, or they were going to lose control, or whatever. And they were having a very
I'm alive. Stand. That's good. So I'm still pondering philosophical problems. I have my many years of philosophical study, academic study under my belt. Recently been interested in analyzing this one complex issue: how two specific theories, naturalism, objective realism, and linguistic uses relate to each other. Asking which comes first, or how uses wherein any linguistic theory functions to get us to the realism part. Like, what are propositions doing? So on truth, quantification on laws. Just one thing I'm thinking about. Very cool. Okay, naturalism, objective realism. Yeah, we'll do that after we watch this video, but I really thought that the book A Spirit of Trust was really effective for me to bridge those two gaps, the idea of like semantics but also normative linguistic use. So That's what I would recommend. But it's also a really big book, and it's kind of crazy. So if this is something that you're really interested in, and like it gets you for months on end, then I would recommend reading this. But of course, I think we try to ground it in a more coherent way in the document with the actual science of conditioning and social dynamics and the feeling of semantic reality. All right, I'm going to continue on.
Very hard time relating to their fear. And I said, well, let's do an exercise. And they said, okay. And I said, well,
Okay,
think
so
of
that
like a
was the Dark
really,
Knight.
okay, first of all, we're going to take the room as frame. All the experiences in the room, right? So you're sitting in a room and you've got, all these sights, all these sounds, this big volume, and let's hold that sort of evenly in the mind with eyes open as the frame of experience. Now think one of these really scary thoughts you've been having, right? Until you start to feel it in your body. But keep the room as frame. So you've got the sense of while you're thinking these thoughts and having these feelings, you want to notice how big and strong they are in the room, right? What percentage of your experience are those sensations? How strong are they actually? And they said, okay. And they were like, and sort of starting to close their eyes. I said, no, eyes open, remember the room. And they were like, oh, okay. And I was like, do you have the thought? And they're like, yeah. And do you have the feeling? And they were like, yeah. And I was like, remember the room, right? And they're like, yeah, I can't do it. I can't make the fear stick. It's just disappearing. It's just disappearing. I can't do it right now with holding the room as frame. And I was like, yes. Like, right.
Yeah, this is the thing that I noticed so far in my practice. It's that if you indulge your attention in such a way that you keep something like that in your thought, so when you're closing your eyes, if you're paying enough attention on your breath, then whatever is trying to break in is just going to be diminished in some way. Perhaps it's still there, but it's going to be diminished if you're still mindful of your breath. So in the same way, you have this type of feeling of, I'd imagine you have this type of negative anxiety or whatever, but as long as you're keeping your attention on something else, it doesn't need to be the room. It could be your breath. It could be, something specific in the room. It could probably be a certain type of thought. But as long as you're putting your attention on something else, you're essentially kicking out or diminishing the percentage of whatever that other thought would be. At least that's what I'm intuiting or experiencing when I do that. I think he's making a more subtle point about what his default state is like, but he's getting there. Okay.
Exactly. That's the point. Right? It doesn't work. You can't, because in order to exaggerate our feelings and emotions, we have to sort of do this thing where we activate what's called the default mode network. We activate something called the PCC in our brain, which is the posterior cingulate gyrus. And when we do that, the room kind of disappears for a second, and our thoughts become super big and strong. Whereas if we were holding the room as frame, with our PCC very deactivated, our thoughts are these wispy little things in the room. I mean, in comparison to physical sensations or colors or whatever, you can barely even find them, right? And so this is basically that just, the vast majority of the time, in other words. Yeah. So whereas most people's default mode network is to have thoughts and feelings be the predominant experience, and the room is there when they need to pay attention to it. They can take a whole shower or drive to work and not even remember any of it. You don't even know if you washed something because you weren't there, you weren't present. Well, if you train to really be present, you can flip over into this other way where it goes, wait a second, when just everything is sort of evenly perceived and thoughts are just these wispy little things, well then the amount of trouble that all of that used to cause is vastly less. And so that's sort of one example that helps to explain what this experience is like. But in other ways, I'm just an ordinary dude, ordinary mammal, dude, hanging out, doing dishes, sweeping the dust bunnies off my floor.
Yeah, the only thing that I would try to maybe point out based on the stuff that we looked at is it might be inappropriate to think about thoughts as being like in reality diminished. Like I think what he's done in his practice is he's built skills of mindfulness that can diminish thoughts in the moment, but it's not that you realize that the thoughts are just like wispy things. It's that you've you've built up a skill that can cut off the thoughts from your automatic way of being. And these thoughts still can be as visceral as touch and feeling like that. Like I think that's kind of the point of how integrated the cortex is with the rest of the brain. Like we can't think about thoughts as like something lesser than feelings. Like the thoughts and feelings are hand in hand. But this specific practice we see allows you to effectively inhibit the DMN. So it's gonna inhibit the thought aspect of your experience in this way. This is a common report for meditators. They become more subtle as well as less frequent, but less in an experiential sense. Right. Yep. So that's what I'm guessing is happening. It's that you've built a practice. You've built the strength of the inhibiting parts of your brain, the parts of your brain that inhibit the DMN. So yes, the DMN is literally, as we've seen, like the activity lessens. It's not that the thoughts weren't there before. It's not that the thoughts are fundamentally wispy. It's that you've done something with your brain. You've built these connections that are now affecting this experience where your thoughts don't have as much control over your experience. So, like, they're not gonna take up that space. They're not gonna make you feel all certain ways. Or all sorts of ways. Experiential wispy for sure. Experientially wispy for sure. I think like when you're not practiced, thoughts are the realest thing though. They're not wispy in some sense. Like when you're, like imagine someone who's lost in TikTok land, right? Like this is their mode of being. They're like highly addicted. Like their entire visceral experience is like literally just this place that they're in and the thoughts that they're having, and it's so automatic. Like they have very little control or mindfulness of what's going on. But that isn't to say that they're wispy. Like this is the entire experience. This is the meat of your experience. And it's just the question is like what type of experience would you want? Would you want more of that control over your own experience in life? Okay. Adam tuned in. Thanks. So I've heard of Hegel's underlying philosophy. He's not really a Western analytic philosopher, but a process phenomena idealist. He wouldn't say naturalism along the lines of Quine's view, would say scientific realism, physicalism, naturalism, independent of any mind is true. He is best classified as a German idealist, often called absolute idealist or process phenomenological idealist in some descriptions, and his views are generally opposed to straightforward scientific realism. Okay. I do not think Adam is Peter. I think Peter's Twitch name is something else, but I could be wrong. I could definitely be wrong with that. Yeah, okay. Let me Right. So you were trying to find how something like naturalism, objective realism connect with linguistic uses. Right, yeah. So I think even though Hegel was in that boat, I think Brandom does a good job of really tuning this to a theory of mind. And granted, Brandom is still not connected to the underlying science that might make sense of these terms that he uses. Like he considers objective realism and he arrives at a conceptual idealism, I think. So he kind of does bridge the gap in a way, but no, I'm Adam. That's nice. Hegel, though, is not denying an objective world, but reconceiving objectivity as rational, historically mediated, and conceptually structured. Okay, I see. So, are you? I guess you would rather have the type of. Oh, Quine is pretty dope. Hell yeah. So yeah, I'm curious what you're trying to hold on to here. Is there an aspect of the physicalist or naturalist aspect that, so are you trying to bridge the science with norms? I'm looking for the problems raised or questions raised. Oh, looking at the problems raised or the questions raised. Okay. Yeah. What do you think are the problems raised or the questions raised? I'm kind of curious. I want to see if our training in part 1 has equipped us to be able to maybe answer some of these. But in the meantime,
so when you say that you hold the room as frame, as an example, that is your sort of your reality for the most part.
Your ground. That's the default, right?
That's your attention.
Most people's default is what's called the default mode network, which is internal thoughts, worries, thoughts of past and future, ruminative thoughts. That's where their brain lives if you don't give them something else to do. Well, me, given nothing else to do, the room predominates, and thoughts are these wispy little things in it.
Gotcha.
Cool. That's a bloody good way to describe it. Holy shit.
Yeah, I agree.
And they can still convey their message, right? So like, you know, and there might be a little feeling and there are little sensations here or whatever, or, you know, but it's what percent of experience, like this much, right? I mean, it's like, you know, what percentage is this little thing happening
I'm
here,
doing
this
him
little
justice
sort of
by having
thought
this at
somewhere here, like, with almost
1.25. He
nothing.
looks
So they
way
can convey their
more
message,
manic.
but they don't become
than-
exaggerated.
than he
Because they don't
probably
become
is
exaggerated.
actually.
There's not that like constantly re-triggering of all these, you know, adrenaline and cortisol and stress chemicals and stuff in the same way that used to happen before. I mean, what most people do with their emotions is like they may be just walking along in a safe place, but then they remember something that happened to them that was really bad, right? You know, and they get angry about it or something. And then those anger chemicals flood their body, and then they lose touch with the space they're in, and more thoughts come up that are angry. And then those thoughts re-trigger more angry chemicals, and then they get angrier. And then because they don't have this perspective, right? And then they just keep re-triggering the chemicals because the perspective is now lost, sort of amplified by the chemicals that are the angry chemicals or whatever, the angry pathways in the brain or the desirous pathways or the sad pathways or whatever. And so and it just gets worse and worse and worse. And somehow they think this is a good idea. It would almost be like a drunk person who
I don't
realized
think
they were drunk.
Consider that this is a good idea.
And then didn't like it, but they just kept drinking. You know, and they just keep slamming them back. And
They don't realize. Like
You know,
even the person that's got the problem with alcohol, like the first step is to realize that you have the problem. So I think that's a lot of the issue. You know, someone who's caught up in TikTok land might not realize that they've just spent 3 hours.
you know, and then just more and more of these sort of things start flooding their brain, and they're losing more and more touch with perspective, and yet they just keep knocking them back, you know, and they're, you know, just like, whoa, man, like maybe.
Oh, I see. Okay, I'm sorry. Which comes first, the conceptual linguistic use that define the object? Object realism part is true. I'm going to say it's naturalistic regardless, yet how we get from word concept to object is what I like to tease out. Yeah, I think it's all grounded in conditioning. So I think we watched the video of me explaining pretty much this yesterday. Oh yeah, I would actually just recommend if you wanted to see my thoughts on this. It was a video I posted yesterday on the channel, and it's literally semantics are normative. so right there, not as compelling of a title as the one to the right here. So it's only got 8 views, but it's covering exactly what you're saying, and the gist is basically that I think at the end of the day, we learn what to think, essentially. So like imagine thoughts are us just or our brain just putting a bunch of aspects of experience together. Some of it might be like some linguistic aspect, and some of it might be some affective aspect, and we arrive at like what we should be feeling in this regard from learning, from, you know, when you're a child and your parent, like when your caregiver is like holding you and like they're kind of saying words and stuff. They're like, not only they're giving you like the sounds and the words that are associated with whatever you're doing or looking at, but they're also giving you the affect. They're showing you with their face, like whether or not something's positive or something's negative or something's scary, you know, like so I think it's that we internalize meaning in this way, and then that affects how we experience it later on. But when we experience objects and meaning in general, like, it feels objective. So that's what gives us this idea that there's some objective realism. Like, it feels objective, and that's something we can also explain, and which we do explain in the document through topics such as predictive processing, salience, and allostasis, body budgeting. Like we learn norms, like, about what things ought to be. So pen. We've learned over a long period of time that this is a pen, but we needed to associate this visual stimulus or stimuli to the thought of that as a pen, and we do that when we, in books or in school, when teachers say, hey, this is a pen. They're telling us rules. They're giving us the rules. And then we arrive at thinking that, oh, this is just true because this is how it is when I see it. And so I think that's the sleight of hand that happens in our life. And we are at this crazy point in our history where we actually have the sophisticated culture and words to be able to actually point out what's going on, which is something that, like Hegel kind of does, but Hegel doesn't have the science to actually point out how this is happening within your brain. Hegel kind of speculates as to what this type of dialectical process is. Okay. Was saying he's a doctor, by the way. Nice. Are we talking about Peter here, or are we talking about this guy? Localizing is important too. How the concepts localize the objects as quantificational items. Are we saying like how they affect the possibility of particulars of them? And finally, the web of beliefs standing together is the theory which forms the whole theory. Yeah, so we can only conceptualize how these different thoughts are connected in our brains, like how different concepts are related to each other. But really, at the end of the day, it's the stuff that we were talking about earlier today with the hippocampus basically taking in associations and compressing that information. And it's very difficult for us to intuit these types of associations in our brain right now. But it is really just connections that have been strengthened together, right? This is just that fire together, wire together. So that's how conceptual relations are formed effectively. All right, but normativity relies on scientific uses of language. On scientific uses of language. Now we are back to square one. Linguistic uses of some property F and success application means conceptual projection of future use as true under condition XYZ. I think my mic is still on. Hello, hello. Oh, that's what I'm into right now. Study. Nice. Volume good here. Nice. Thank you. Thank you for the feedback there. And success application means conceptual projection of future use as true under condition XYZ. F is true, where F is redness, and it will continue to hold over time. Right, we could try to like make sense of like the rules. Like we could try to conceptualize what those rules actually are. But at the end of the day, it's just neurodynamics. It's just connections being built. And we can, and like us thinking about the rules, like us thinking about the underlying structure is just a conscious experience we're having, but it's not actually, we're not actually interfacing with the actual underlying connection in our brain. It's a different process that leads to the experience of us thinking about the thing itself. Like self-conscious thought isn't actually, you know, the same thing as whatever we think is actually true underneath the hood. And of course, there's this, you know, we have to diminish this concept of truth, because really truth is most fundamentally just that feeling we have in the moment when we think that this thing is true. So, yeah, I think linguistic use is really important. We internalize information via linguistics. Like linguistics allow us, like our language allows us to internalize sophisticated patterns of thought. Without the language, we wouldn't be able to internalize this type of knowledge, right? This type of habitual thought. Like you can imagine that these are procedures, and the like language allows our procedural thought to be more complex. But at the end of the day, it is just the internalization of stimulus response loops. Oh, if a random teacher was throwing in that much science, I'd be skeptical. Right, the teacher shouldn't be talking about all that stuff. I think the teacher would just tell you what is, right? Like that's why it's difficult. The teacher just tells you that this is a pen, so it's kind of ambiguous as to whether they're teaching you a rule or if they're teaching you knowledge, like some sort of objective knowledge. And the teacher isn't a philosopher, so the teacher's probably, nor is the teacher probably, a neuroscience student. So, yeah, the teacher doesn't realize what they're doing either. So that's why, we're kind of at this point where we have this nice privileged view of what's actually going on, and we're creating our philosophy out of it. Okay, let me refresh the webpage. Yeah, I don't know. I hear other Twitch channel audio, but Stans is off for me. Might be a browser issue. No problem here. It was my overlooked audio setting for the page. Audio was muted. Ah, very nice. If you want certainty, philosophers are the last place you should be looking. Unless the philosopher tells you that the only thing that you can be certain of is uncertainty. And right, yeah, even in the moments where you could say that the only thing you could be certain of is your conscious experience. Yeah, there is still something fundamentally true about, or intuitive, I should say, about the fact that the only thing that's true is your experience right now, regardless of what that experience is. But once you start trying to conceptualize what that experience is, you've obviously, I always say that you've already done some interpretive thing. All right, was talking about the guy on YouTube. I don't mind him using science because doctor. Oh, you're talking about the other guy. Okay, I see. Oh, okay. You're saying this guy because he started talking about the DMN and the I don't know, that gyrus. But he's a doctor, so it's fine. All right, they've made a career out of being uncertain. Right? Unless certainty is possible, yet not here. I don't think certainty is possible outside of experience. I think certainty is just a way to describe your experience of knowing, or of thinking something's true. I think that's as far as we could go with this. I mean, unless we start talking about certainty as what science tells us. it's more so like a level of reliability. It's more of like a standard or a normative methodology. But the most fundamental view of certainty is a feeling, is the experiential feeling of certainty.
You know, and so it's nice to have a brain that has been trained to not do that. You know, it's not like, you know, like continued stimulation can't, you know, cause reactive chemicals. They do, but they're triggered by what's going on in the world in a way that is not like just, you know, sort of the world disappearing, thoughts becoming this huge thing, and then, you know.
So I'm curious, what's the threshold for being enlightened here?
Or that I have perfect intelligence or clarity or anything like that, because I'm still a mammal. But it is much better. It's much better to not have that being caught and stuff be the default mode.
Yeah, I can imagine that. Like, while you're thinking of that, I was thinking about literally a thought I had today that for like a good hour, I was like, geez, I feel crap about that thought. I feel not so good about that. So no, it's really interesting. It's a really interesting insight that I guess I've been prodding Tom for that insight for ages, but of course he's not there yet, so he couldn't give me that insight, which is beautiful. Exactly. So it's
what always gets me is like there'll be a time where like I perhaps think about something, but then I forget what I thought about, but then I remembered that I had thought about something that made me feel a certain way, or like made me feel like I needed to do something, or made me feel like something bad is going to happen. And I don't even know what that thought was, but because there's this possibility that that whatever I thought about was important, then I'm now plagued with this ambiguous thought of like doom, and that's always a bummer. And I should meditate on that when that happens again, though. I don't think that's happened in a while, but I always found that was very fun, very interesting. Not fun in a positive way, but very neat. Okay. He claims our hot ship end of Theravadin path. Other than that, you'd have to ask him. The other thing that I'm struggling with still is like wouldn't someone who's enlightened understand how much of an effect identifying as enlightened would have on your experience, and thus would not want to indulge that part of your brain? Like, so then there's almost like in my mind, it's almost an oxymoron to say you're enlightened, or maybe not an oxymoron, but it's like paradoxical. Some say that, yes. Okay, I see. For Theravadin's enlightenment has 4 stages measured by how purified the mind becomes, basically. Okay, I mean, then if that's the way that we were going to measure enlightenment, then yeah, you could definitely be enlightened if you get to a certain point. I would want to, of course, have some empirical measure for that, but that might be very difficult. But Buddha okayed it in a sense to measure it in those 4 stages. Okay. There are quite specific criteria. Okay, so perhaps even if there are phenomenological criteria, that would be fine. They use the 10 Fetter model. Okay. We'll have to go into that during meditation month. And what's the usual path, or like the time length for reaching the full enlightenment level? Like how long with how much practice usually causes someone to reach? I know it's terrible to have this type of expectation in your mind in your practice, but like, what is the usual like roadmap for people in their path to enlightenment?
You know, I think that was a perfect way to describe it. I actually
unlikely in this lifetime.
How that kind of works and how you're moving about your day-to-day life. It also clears questions.
What if I just gave up everything and I just practice every waking moment of my life? Wouldn't I reach it eventually? Or are you saying it's literally not possible throughout an entire lifetime? Or are you saying that I should have started sooner? Like it's something like playing the piano, like that we've discussed previously, or or chess, where you have to start when you're a kid, or else you're not going to be able to reach that type of stage. It's just profoundly difficult. Okay, I see. Equated to Nobel Prize. Is it that rare? Good morning, Birdbanes. What's good? We're learning how to be enlightened. And we've determined that it's too difficult. Quite rare, yes. I see. The lower stage is less rare. Isn't there a switch on the wall for that? If only. Oh, I see. Enlightened. Very nice. Remember, 4 stages. Are like 3 out of 4 of the stages fine, or?
You know, like in terms of how you just move through space, you know, and how you exist. So
let me just jump in and say that conversation that you and I have, Odie, goes something like this. So you're progressing along the path of insight, right, Dad? Yeah, I am. Well, go ahead, levitate. Let's see it. Go ahead, prove it. So where do you go from there? And I mean, it's funny.
Oh, is this
there
family?
is that perception. there is that perception out there, right? Of like, okay, well, you're enlightened, so that means you're a godly being, and you are able to you have superpowers, right? So prove it, show us. And it's really tough to navigate through. The way you just explained that, Daniel, is a way to bring it to life on what it really is on a daily basis, as opposed to what it's been described at or promoted as, or in the moment. All right, so should we just go there then?
Nice.
We're loving doing this stuff, you guys. If you want to.
Alrighty. Very cool. I think we might be at the end of the road here. So there is enlightened. Where's the delightened? True. What would delightment be? I think delightment would be what we've been talking about, like addictions. So like, you know, you get into that point where you use TikTok for 4 hours a day. I think that would be delightment. Maybe, you know, alcohol addiction, we could say, is like a sort of delightment where your focus is literally forced away from you. It's as if like the alcohol is just grabbing your attention and pulling it towards it in such a way where you are so far away from enlightenment that you have to work through a lot before you could even start training for enlightenment. First stage, they say a monk working hard for a year is likely to reach it. Okay. I don't like the term enlightenment. We have lost it to vagueness and bastardization, but if you step into the Burmese system, there are very specific definitions. TikTok scrambles your brain. TikTok does indeed scramble your brain, unfortunately. It does all kinds of things that affect your attention, your ability to feel positive emotion during the day. It affects your ability to sleep. We could probably go farther into that, but alcohol is delightment noted. I mean, I would say any of these addictions, you know, certainly any drug addiction would cause that. There's some addictions that wouldn't do it though. Like I feel like a coffee addiction isn't going to do that. Video game addiction probably wouldn't do that until you get like to a point where you have to be playing like all day or something. I don't know. I'm just kind of shooting the bit, let's just say. I like that Krishnamurti said, "Don't become enlightened. That is a horrible idea." What do you think they meant with that one? Isn't TikTok a digital documentation of human stream of consciousness that leads to sighing? The Hollow Knight incident. True. I'm looking forward to being delightened again when the next big game comes out. Isn't TikTok a digital documentation of human stream of consciousness that leads to sighing? I'm not sure where the sighing comes in. But yeah, what TikTok isn't like what we're really looking at. It's the engagement with TikTok that's affecting your focus and your let's just say your dopamine tolerance. you know, regardless of whether TikTok is like good in a broad sense or not, it's certainly for a singular individual, it affects their ability to pay attention during the day. I think he meant it will corrupt your ego and you shouldn't think about yourself as arriving to some final thing. Okay, so similar to that thought that I had mentioned, but this one's even further than that. You don't want to ever arrive, right? You want to keep that journey open for the rest of your life. It's that's yet another gold mine for positive emotion, to always be working towards something that you can never hit. Oh, I sigh when I see TikTok vids on YouTube. It's mostly, what is this nonsense I see? It leads to sighing or cringing, you could say. Right? But you have to admit it's compelling. I mean, same with YouTube Shorts, right? YouTube Shorts will do the trick. I mean, YouTube will do the trick, just not to the same extent. There's also this quote from the main Thai Buddhist authority: do not make yourself into anything. Do not be a meditator. Do not become enlightened. When you sit, let it be. When you walk, let it be. So this is basically a chill out on your identifications, identifying with stuff. Now, for the sake of our document here, I think that we point out that it is actually quite effective to identify with certain things. And, you know, in part 1, we even say, hey, like, identify with the process rather than some static position. Like, identify with the process of noticing something and pursuing engagement with the unknown, and I don't know, all that Jordan Peterson-esque stuff. Stan, are you a naive realist, one who thinks no use of human sense or concepts or phenomena is necessary to view that there's just real stuff out there, independent of any conscious being? Quantum realists say in our world there are basic natural laws and structures we describe as physical fields work in some funny way, and then some particles like objects come to be real. Causality is implied in a theory of time. When we're talking about real, I want to always separate the context that we're in. So if we're talking about experience and we're saying real is things that we experience as real, right? So like when I see that this is a pen and I think that this is a pen, like really what's happening is an experience of this being real. And in that case, I always want to think about the phenomena. And I think about concepts, and I think about meaning, and I think about experience, and all these things that have to do with consciousness. Yes, absolutely. I should make it so that whenever someone does... we should make it be... what's the word? Canon. We should make it be canon that Sherma's holding a pen here. Sherma's got a pen and hitting a pen with the other thing. Yeah, but then like if we're going to talk about real in that way, then we've got this nice consciousness view, this non-dualistic view of what real is, and it's always, you know, this is the most fundamental real that we interface with ever. It's the only, you know, this is like really it. It's just consciousness. What's appearing in consciousness, it's affected by all these things that are in our brain. It has all these different aspects of our experience, all that. But then if we're talking like within this view of consciousness, within our own conceptual thinking, we can conceptualize other domains or other concepts in which real could mean something. So we conceptualize what the physical world is. Now the physical world is not like full of objects. Full of objects is just interpretive. That's what we are interpreting it as being. But it's really just, you know, it would just be matter in some sense. But even that is some interpretive layer. Like even that's going a little too far. You know, we really don't know what the physical world just like is fundamentally. So we interpret things. We interpret based on our empirical observations and, you know, empirical behaviors and all that. You know, we come up with these categories. Mereological nihilism creeping in. Right, though I think we've looked up mereological nihilism and I think put it to bed. I don't recall, but so yeah, when we're talking about like physics and all that, we can talk about physics as dealing with real, but that's like just a different, you know, context that we're talking about real in, and I would want to keep that separate. So I know that's not the most satisfying for people, because they're so used to the most fundamental real as pertaining to external objects, like this being a pen. But I'm here to say, hey, the thought of a pen is a thought. But it certainly feels as though it's objective, and it feels as though it is non-psychological in the sense that it would still be there if there wasn't a person to think about it. Like it's constitutive of the very concept that I understand about a pen, that if this object was in the world 200 million years ago, that it would still be a pen in that world. There would just there would just be no one to think about it as a pen. Deep cleansing from eating Taco Bell is real. Oh man, I miss Taco Bell. I gotta get some Taco Bell. All right, I think there might be two levels of realness. One is what we perceive exterior of our bodies, and another is internal. If I feel hungry, it's a real sensation. If I suppress a sneeze, I feel horrible. I always want to caution us from making like a this many levels system, right? Like some certain rule set about how we ought to conceptualize the world. Like we could come up with 10 levels of realness, right? Now I'm trying to point out that the most fundamental realness that we can conceptualize is that of conscious experience and of meaning, but we could come up with a bunch of different contexts in which realness makes sense. Now our understanding of predictive processing, as we've discussed over the past few days, is such that even when it seems like I'm looking at this external object, it's really we're starting with our memory and our internal models, and our experience is affected when those models are conditioned by or constrained by the stimuli that the photons from bouncing off of this pen actually affect on my within my brain. So you're not a scientific realist. The domain of reality of real for you is still a concept. That's for philosophers to worry about. Subjectivism to skepticism. Right, so like I always try to navigate this space where I can't say that we're physicalist, because we don't say that the physical world is constituting like the ontology that we experience as being real. And I can't say I'm an idealist in the sense that my conscious experience is affecting the physical world, because these are just two different domains that I'm conceptualizing. Like it is a manifestation of my own conceptual experience that the physical is what is affecting my conscious experience, but the realness that I experience when I'm thinking about things and when I think that this is a pen, like that's all happening within consciousness. The concept of the physical world is happening within consciousness. It's just that this concept seems to have properties that have effects on how I think about physical objects. But all the thinking about properties and relations, all this is still a mental exercise. It's all happening. It's all happening in our conscious experience. And it's all happening because of all the stuff that we talked about today, all the memory stuff that we talked about today. And habits of thought are simply those rationalizations that we have of like, this is a pen because it's shaped like this and because it has certain properties. Like what I just did there is I utilized internalized procedural thoughts that I've habitualized over a long time. I've reinforced over a long time. It's going to be very difficult for me to forget those norms, those rules of what this thing is. So, all right, pen drop. Let's call it a day. Thanks for engaging with these topics, though. I do enjoy all these topics and these discussions. So, thanks for coming to chill, and we'll be working on, what are we doing tomorrow? The mechanics of autopilot. So I think that what I mean by that is we're going to be dealing with I think we're going to be dealing with like the lowest level players of automatic behaviors. So yeah, the mechanics of autopilot. Yeah, this is going to be like the basal ganglia, reflexes, motor skills. We have to do that tomorrow. We got, oh, hell yeah, conflict monitoring. We have to do all that stuff before we could get to the fun cognitive biases that I think we might make a video out of. I don't think if we do a video essay on cognitive biases, I don't think we're going to go as deep as the mechanics of autopilot, but it's going to be important that we have that in our minds so that we could perhaps leverage any of that information when we're talking about these things. All right. Yeah, have a good rest of the day. Oh, let me senses receive stimuli from the external world, but these senses do not always translate well to internal bodily processes. Hungry, pee, etc. Sensations do not rely on traditional senses that deal with the external world. Right, but we have all sorts of interoceptive senses, you could say, that are quite subtle and are different than external senses, but they're more evolutionarily fundamental. And so we can't discount them. And obviously a lot of those senses can become conscious. But a lot of the time they become conscious without realizing they're becoming conscious. That's kind of the whole idea here. Like our insula interprets or fails to interpret them in such a way. All right, I'm getting stun locked here. What is smart detection? What's wrong with this message? Auto-modded. I'm going to read it. Then could, in theory, a possible being, God or an evil scientist, could have created all your concepts, any new data, a pen at time is fabricated data on metaphysics, moving from internalism, mental reality, to a likely reality is tough road. Without a metaphysical worldview, a true ontology of the ultimate conception of the world for internalism to be true. I guess the thing that I'm pointing out is that each person kind of has their own understanding. So even though it seems like we're experiencing the same world, like when I put this object up, we all have this thought that's a pen. I describe that as these thoughts are pragmatically similar in the sense that if I asked you, hey, is this a pen? You would say yes. But really the experience that we're having is different. And I always say different meaningfully, like literally the meaning that we experience is different because we might have different associations of what this thing is. If you were, I don't know, if you really like pens, you're going to have a different type of experience. If you understand pens to be really related to your work, you're going to have a different experience. You might have more of an appreciation. All these things happen like unknowingly in your conscious experience. But obviously the main takeaways are very clear to you. It's like, that's a pen. And so yeah, I don't think anyone's like choosing these concepts. These concepts are just our experience. When I'm talking about concepts, I'm not talking about some actual set of concepts somewhere in the world. I'm only conceptualizing my own brain activity when I talk about concepts. And the only way I can think about these concepts is through this brain activity. So it's this like really odd exercise in trying to conceptualize. It's like very theoretical. It's not actually what's going on in the brain. The only way we can think about what's going on in the brain is what I've discussed, all that neuroscience. But then the bridge that we use in part 1 of the document to bridge between, the philosophical, theoretical conceptualizing what this content is And what's actually happening in the physical world is we use schema theory as our point. So this is where we actually get to where we try to conceptualize our understanding. And this is a theoretical activity, as I said, and we can leverage schema theory to help us out. Schema theory talks about these different thoughts that we're having when we think about concepts as schemas, activated schemas. So, but once again, even that is too you know, reductive of what's actually going on under the hood, which is like this, you know, really crazy, complex neurodynamic, dynamical system, or however they talk about it. All right, I gotta get out of here. Have a good rest of the day, everyone. See you later.